So at this point, we've spent a lot of time talking about accelerated objects and predicting what they're going to do. But physics has more to it than that. Sometimes finding out what the acceleration is going to be is actually more trouble than predicting what it'll do once we know that. And in order to describe accelerations, we have to talk about forces. In short, a force is a push or pull that can cause accelerations on an object. And we've talked about things like a car that's accelerating or a projectile flying through the air that's accelerating. And we talked a lot about the what, but we never really talked about the why. And that's what the next big chunk of this class is going to be, is we're going to find out why did the car slow down at 3 meters per second per second. Forces explain accelerations. It's where they come from. Now, there are tons of forces out there, but for now we're going to study about 5 or 6 of them. So I want to introduce you to some of the more common forces that you'll see in physics. The first one is the force of gravity, which just says that anytime you've got two masses that are in the general vicinity of each other, then they're going to attract each other. And the bigger the mass is, or the smaller their distance is between them, you'll get a stronger force of gravity. The next major force that we're going to use is the force of tension, which is a force that's exerted by a rope. The basic idea is when you pull on a rope, that rope does not want to just break in half. So instead what it does is it applies a force on you to prevent you from breaking the rope. Ropes are useful for transmitting forces over a distance. So if you want to pull on your friend and he's 30 feet away, you can't do it with your body, except for gravity, but that's very weak. And if you want to pull on him, the only way you can really do it over a distance is by using a rope of some sort. So we call that a force of tension. Next up, we've got the normal force, and this one's a little unusual. The way the normal force works is when you push on an object, unless it's putty or something like that, generally the object actually pushes back on you. If you push your hand against a wall, the wall will prevent you from going through it. So anytime you have an object that's sturdy enough that you can't go through it, the reason you can't go through it is because it pushes back on you, and we call that the normal force. By the way, in physics, sometimes when you see the word normal, it means perpendicular. So when you push on an object, it pushes in a perpendicular direction back against you. Next up, we've got the force of friction, and what friction always does is it slows objects down. So if you have an object that's sliding to the right, there will be a force of friction to the left. Or if you have an object sliding to the left, there will be a force of friction to the right. You can even have friction if something's not moving. Maybe you've had a large object that you've tried to move, maybe furniture or something like that, and you pushed it really, really hard, but it still wouldn't move at all. That's because of the force of friction that was opposing your push. By the way, I bolded these for you to make this a little easier for you to read because you might want to go back to this and reference it once in a while, or maybe even open this in a new window because we're going to be spending a lot of time working on forces after this. Anyway, the last one that I want to introduce to you right now is a force from a spring, and we don't have a special name for it except maybe elastic force, but I just call it force from a spring. And springs are a little unusual because they can act kind of like a rope, because if you stretch a spring, then it will pull against you. But if you compress a spring, then it will also push against you in that case. So springs can kind of go either way. They can have sort of a normal force and sort of a force of tension. So we have a whole extra category for them. And we can also have an other category where maybe there's a force from just some random object, so your hand's pushing on something or whatnot. So you'll encounter random forces sometimes, but these 5 are going to describe most of the forces that you encounter in the problems to come.